Hi, I'm Lars Anderson, a volunteer for the San Francisco Sailing Science Center. And I wanted to show today one of the exhibits that we're working on. It's called Density Drop. And it's really very simple. It's two water columns. You can see the water level here. They're 4 feet from the top of the water column down to the base, to the bottom. And we use these to show how objects sink through water at different rates based on their density or the surface area that's resisting that flow down the water column. So it's pretty straightforward. I'm going to chop some objects in there and see how fast they sink. And you can watch for yourself, see what happens. I'm going to start with a simple one. So I have two cylinders. One's made out of acrylic, this clear one, and one's made out of fiberglass. And the fiberglass is a much more dense material than the acrylic is. But they are the same shape, same size, same volume that they occupy. So I'm going to drop these in the tanks and we'll see which one goes to the bottom first. So the fiberglass is on the right, the acrylic's on the left here. So from the camera, that's the acrylic. All right, here we go. We're going to drop these now. And you can see that that white fiberglass cylinder dropped much faster. The other one's still coming down and just now hitting the bottom. So even though they have the same volume, the same size and shape, the fiberglass is so much more dense that it sank much more quickly through the water column. But it's not all about weight and density. There's some other things going on too when things sink through the water. And it's kind of interesting because when you sail in a boat, you're actually dealing with a lot of fluid motion and flow, whether it's the air over the sails or whether it's the hull of the boat moving through the water, another fluid. So we're concerned about that because we want to maximize the efficiency of the airflow over the sails and minimize the drag or the resistance in the water column that's slowing that boat down from moving. So this is an example of what happens when you have a lot of surface area, even though you have the same density of material. So we have an acrylic donut, looks like this, and we have another acrylic donut within a donut. I've just added one of these inside a larger donut. And this one weighs about twice as much as this one. So I'm going to drop these in the water column with this orientation so they're flat, and we'll see which one hits the bottom first. So the light one's on this side over here. The heavy one is on this side over here. And I'll release these at the same time. Here they go. So you can see the lighter one is sinking at a much higher rate. It's going to hit the bottom first, than the heavy one. Now the heavy one's just getting down. So even though this one on this side over here was heavier, it took longer to get to the bottom because of that surface area, and that double donut was much larger than the surface area in the single donut.